Hello, calculus students. We are currently in chapter 2. We just started lesson 2.1 and talking about limits. Here are our notes. I did skip over the first warm-up or intro to limits. We did talk about definition of a limit, and it reads as the limit as x approaches c for a function equals L, and L is going to be defined as a y value. So as we approach an x value, we're looking at our y values. What are they converging to? Let me just kind of scroll through here. This is what we did on Monday. We did some direct substitution. You guys had homework on these problems. And I believe we're on this concept called one-sided limits. So picking up right here, one-sided limits. Earlier I said when x approaches 0 and x approaches 3, as you approach these numbers, I didn't specify which direction. We're just approaching those numbers. And when you approach it, you can approach it from the right or from the left. So in this example, or in this demonstration, right here, if I'm approaching C from the right-hand side, then that means I start on the right of C, and as I get closer to C on the right-hand side, X value is getting closer. You can see that where your Y value is converging to. And again, your limit is going to be a Y value. And it is noted as a little plus sign right here. So if you see a limit as x approaches C with a little plus sign, that means it's a one-sided limit, and you look on the right side of C. Now there's a left side, and that's going to be noted as a little negative sign, and that is the left side. And as x approaches C from the left side of C, what are your Y values converging to? And that's the point of one-sided limits. I want to talk about our example, y equals int x, an integer function. I want to go ahead and graph it, and then I'm going to probably pause the video and introduce how do you graph this with a graphing calculator. But the integer function, I'm just going to go ahead and assume that you understand the integer function. It actually looks like this. I think you've seen it before. It's like a step function. And this is what it looks like if you were to graph it. Let me just jump down here. So just to review this, if I said integer, let's go 1.5. So that would be right here. If I put a value of x as 1.5, your y value is going to be a 1. If I put integer of 1.5, or change that from 1.5 to about 1.9, almost 2, but it's actually going to be a 1. The integer, the int function, the integer function of 1.9999 will be a 1. Now, once you get to integer 2, that would be a 2. So as a step function, it gets really confusing when you put in a negative value. For example, if I put in integer -0.5, that's going to equal -1. Okay, so why are we looking at this? Well, this kind of shows us this limit right here is x approaches 1 from the right-hand side. So here's your 1, and I'm looking at the right side of 1, and that tells me my y values are going to be 1. If we look at the limit as x approaches 1 from the the left-hand side, that means I'm looking on this side of 1, and my y values are approaching, and that y value is going to be 0. So here we have the first time where our limits are not going to equal the same y value. From the right side and the left side are different y values, and you can see that there's a jump happening at x equal to 1. So this tells us, leads into the existence of a limit. And if the right side, or say in this case, the left side and the right side, if they equal the same y value, then the whole limit is the same y value. So the left side and the right side, if they are equal to each other, then that limit exists. So if I go back to our beginning problem, of this section, the limit as x approaches 0 for sine x over x. And this is the graph, if you remember. Just go ahead and scroll up if you forget what it looks like. It's going to look something like this. It oscillates, and then it goes up, and then it oscillates throughout the x-axis. And this limit right here, we said, is 1. And we got that because we looked at the right side, and then we looked at the left side, and they're both converging to the same y value. So if I had a function, and let me just give you some scenarios here. If I graph a function and it looks something like this, that limit is not going to exist at whatever x value this is. I'll just say it's 3. So if I said the limit as x approaches 3 for this function, it's not. It doesn't actually go to a y. So we're going to say it does not exist. We're going to DNE, does not exist. Unlike the one to the left of this one does exist. It does converge to a y value of 1. So if you have something like this, that limit does exist. If you have something like this, that limit does exist. If you have something like this, that limit does not exist. It does not. Think of these two strings have to connect. Even though if there's a hole, the limit does exist. Just like this would be a hole right here. This would be a hole right there. But it's connected. The right side and the left side, and this is the right side. They're both converging to the same y value. Okay, so the best way to do this is to probably just give some examples. And I'm going to stop here, and I'll pick up the video. I'm going to show you how to use the graphing calculator, the integer function, and then I'm going to go ahead. The next video will be some problems to take a look at.